Hi, we're going to be continuing talking about chapter 4 of the Savitch book. We are working on procedural abstraction part of it. We just finished programming defined functions, and we're going to talk about procedural abstraction. So what is the procedural abstraction? We start looking at it as a black box. So we don't know what's inside the box, but we know how to use it. So the example of this can be in a car, we have a transmission, we have a brake, we have engine. We don't have no idea how they work. All we know is if we put a D, it's going to go forward. If we put an R, the car is going to go backward. We know that we have to start the engine before we can drive. And we know that if we want to stop the car, we can push the brake. But we don't know the detail of it. So that's called the black box analogy. And we saw this in previous chapter, not chapter, section, when we start talking about predefined functions. When we were using predefined functions, like square root, POW, absolute value, and all those functions, we didn't know how the code was. All we knew is how to use them. So we're going to use that analogy for our functions. That means the people who are going to be using our functions, they're only going to know about the name of the function and how it can be used. So they don't know what the detail of my code is. It's just they know how to use it. So we're going to use that for, first of all, information hiding. So if I am selling my code, if I am not giving my code for free, then I don't want people to know what my code detail is about. So they would come in and buy my function and use it. And the second part of it is when some changes need to be done. So let's say 100 people out there are using the function that I created. I don't have to notify them about the new function. I just go and change the internal things, and they are using the signature of the function. The declaration of the function is going to stay the same. As long as it's going to stay the same, the internal code can change. That's not going to be a problem. And of course, they cannot see my code. So this is the way we're going to be thinking about our functions. So we're thinking about the black box theory, meaning that people are not going to be looking at our code. So when we're writing the comments for the function declaration, those comments has to be descriptive enough for the user of our function to know, first of all, if this is the function they want. Second of all, how can they use it? So this is a display 4.7. So it says that we have this declaration over here. Let me get my annotation. So we have this function declaration over here. And the definition can be written differently. And as I said many times, people write code differently. You might write it one way, I might write it differently. It doesn't matter as far as the result is going to be correct. People can write different types of code. So we are not picky about how this is written. We just worry about what is it going to do, what's happening with it. So first of all, you got to keep in mind that one function is going to do one task, and that's it. We are not going to write one function and put everything in there. That's the first rule. One function is going to do one task. Then we go on, and we are using this same analogy of the black box that people would know about our functions through the comments, but they are not going to get the code that we are writing for that function. So I picked up example, and I'm going to show you how your book is proceeding with this and how I would do it. And you guys can pick either one, that's fine. It's not a big, huge difference with it. So the function is called get total. So your book is talking about precondition and post-condition. What do we need to do? What's going to happen after the function is called? So it says user will enter a list of egg counts followed by a negative number. And the post-condition is it's going to return a number equal to the sum of all eggs. I like to keep it the way that we were talking about it. So I'm sticking with input, processing, output. So if I have a function like this, my processing or description goes on the top. What is it going to do? My input is none. I don't have any input coming into this function. So if I had any input, it would go in as a parameter. For chapter 4, our inputs are coming in as a parameter. And what is going out of my function, what is coming out of my function, that would be the sum of my egg counts. So it would be this one. So whatever goes in there, what's coming out. So this is just the input function. So it's a part that we are using to get the information from the user and return the sum. So the comment has to say what is the parameters. If we need any parameters, that would be input for now for this chapter. And what it's going to describe what is the return value and what's happening with this one. Another thing that we have to keep in mind is whatever variable we use in the function has to be declared inside of it. We are not going to use any global variables. So let me write it down here. No global variables. So your variables that you need inside your function either is going to come in through the parameter or you declare it in there. So the function are self-contained modules, so we can take it and put it in other places and it's going to work. We try to reduce or eliminate any kind of a dependencies that this function is going to have to anything else. So one way of using functions, we break down everything into the function, and different people are going to write different functions, and then we're going to put it together. We have to have a meaningful name for the formal parameter and meaningful name for our function name. So it makes sense when you look at it. So later on, you might use the same name that you have it in your program. We don't want to do that right now. For you to get used to it, that the name of the parameter does not need to match the name when we're calling it. The reason for that is we can take this function and put it in another program and it's going to work. So let's say that I have a price in this program. So the price is going to go to my function, and in another program, they call it amount. So my function is going to function, it doesn't matter if you call it price or amount or whatever you want to call it. My function is going to receive that, it's going to calculate something, and it's going to return the result. So if we look at the day's total cost example, we have a number or the price coming in, and then the total cost is coming out. We have comments that's going to explain what is this function doing, what is coming into it, what is going out of it. So number of items, and so including 5% sales tax, number of items, and the price for each. So that's coming in here. So this number could potentially be called number of items to be more descriptive, or number, that's fine, but we are explaining what is the number, what is the price. So the price is for each item price, number of items, price for each item. Okay, so this is an example that your book has, and it's going over calculating pizza. So we're comparing two pizzas to see which one is more cost efficient. So which one is better to buy. So next time before you buy a medium size or a large size, let's see which one is going to be better price. So how do we do that? So we want to get the lowest cost per square inch. So every time we want to compare things, we're going to compare the unit price, not the whole thing. So we got to find out what's the unit price, then we can compare it. So we're going to get the diameter of a pizza. We are going to figure out the area and then calculate the square we're going to calculate the area. So what is for my whole program? So we're going to take the whole program, we're going to break it down to a smaller piece. This is what you're doing in your design document. So what's coming into the program? The diameter of two sizes of pizza, a small one and large one, for example. I need the diameter for each one of them. I need the cost of each pizza, and then that will be my input that's coming into my program. The output is going to be the cost per square inch of each pizza, which one is better by. So we're going to compare these two, and we're going to find which one is better. And if they are the same price, we're going to suggest the smaller size. So we got to understand the requirement before we move on. Okay, so we're going to take the whole thing, we're going to break it down to subtasks. I did that for the template in design document, so you're going to be looking at that. So the first one is the input. What is the input to this program? The second one is going to be computing the price per inch for a smaller pizza, computing the price per inch for larger pizza, and determine which size is better by, and output the result. Now, if you look at these, number 2 and number 3 are exactly the same thing. We are computing the unit price per inch for a smaller one or larger one, but the computation is just the same computation. We're going to have some variable changes, but the whole thing is a computation of this. So these two basically are the same thing, that we can just use one formula for both of them. So if we merge those two, then we can move on to see what we can do. So we need to find a name for this function. So it's saying that the calculation for subtask is the same as the calculation. So what are we calculating? We're calculating the unit price. So maybe the good name would be a unit price. You can call it something else, but you cannot call it X, Y, or Z. You're going to have some meaningful name. I struggle with coming up with good names, but as you practice, you're going to learn more and more to come up with the better names. Okay, now we are going to put the name. We are going to put the parameters in there. We're going to put the data type for the return. And then we're going to be explaining what's happening with this. Okay, so remember, the person who's going to be using your function, this is all they see. They don't see your code. They don't see anything else. This is what they see. So you're going to have some, you don't want to write too much. On the other side, you don't want to write too little. Excuse me. So price per square inch, then maybe we can use that as a name for the name of the function. So when you look at the description, sometimes we can pick up the name of the function from the description. So that would be my output, that would be my input. In general, what's going out of my function, what's going into my function. I like to see it visual. I put it in the paper, I draw a line. What's coming into my function, what's going out of my function, what is this function doing? So for chapter 4, everything that comes into the function is coming into the parameter, and we learned it in previous section, is called by value, meaning that it doesn't pass the actual variable, it's going to make a copy of it and send it in. And then for chapter 4, you're going to have only one thing coming out of your function. That's all we're going to do. We don't have anything else. We just going to have one thing coming out of the function. Okay, so first thing first, we need to ask the user for the input. We talked about what do we need for the input from the user. We need the diameter for large, price for large, diameter for a small, price for a small pizza. Number 4 is going to compare the cost per square for each one of these things to see which one is a better one, to basically calculate which one is better. And then we're going to do the output. We're going to give the result to the user. So if you look at it from what we were talking about, this is my input, this is my processing, this is my output. Of course, the processing, I have 2 sections for processing. I have this one and number 2 that we talked about it in the previous slide. So this is my second part or first part of my processing. Remember, one of the things I'm asking you for your design document is, can you break it down to the smaller pieces? So in this case, we are broken down our processing in 2 parts. One is compare cost per square inch. Before that, I have to create or calculate the cost for a square inch. So how do I do that? First, remember, I'm reading the diameter, so I have to find the radius. When I get the radius, I'm going to use pi r squared to find the area of the circle, pizza, and then we can calculate price divided by area to get our unit price. So this is part of our design document. What we're doing here is something that you're going to do it in your design document. And you can see we are not coding it. We are thinking about what we need to do. And that's your design document. Okay, so pseudocode is what? It's a mixture of C++ and English. I am asking you guys to stay away from C++ as much as possible. The reason for that is when you're doing your design, I don't want you to think about coding. So you're going to think about the problem, you're going to solve the problem, you're going to write the algorithm design document, and then you're going to write your pseudocode, and you take your pseudocode and you translate it to the actual code. So we are not worried about the syntax. We are not worried about, okay, I missed this one, I missed that one, where did this go? And basically looking at a big, huge problem. So in this case, we are creating the unit price pseudocode. We are saying, remember, these are the steps that you have it in your design document. First, this is what you're explaining what is supposed to be done. Based on this one, you're going to take this one and you're going to create a pseudocode similar to this. These are all part of your design document. So we can put the word return over here. We might put something in there, but we are not going to put C in, C out, or things in that manner. We're just going to write it down. And as you go forward and you get more comfortable with these things, we can lay back some of these things that I'm pushing on you guys, because we need to practice this. When you get it, then we can kind of let some of them go. But this is what we're doing. So you know what the pseudocode is. If you didn't know it by now, now you know it. Now, when we're done with our design document and we wrote all the pseudocode for all the parts, now we're going to take those pseudocode and we're going to translate that to coding. Now, inside the main, remember we have 3 sections for the function: function declaration, function definition, and function call. So we're going to have function call inside the main. So I have to have some variable, the unit price small, unit price large, and then I can call the unit price with these variables. So my diameter is small, price is small, are coming into this function. It's going to call with this, and the return value is going to go into unit price. And if I do the large one, I basically passing a different variable, different values, and then I'm going to get the unit price for large. So unit price function internally, that's all it's going to do. So it's going to get a diameter, and it's going to get a price, and it's going to calculate the unit price, and it's going to return it. So even if it's a small or large or whatever it is, it doesn't care. Calculation is going to be the same. So most of the time when we start writing functions, we write function for things like this. We would write 2 functions, one for large, one for small, while we see that the actual coding is exactly the same. So that might happen, and it's okay. So you go back and you see this function code is exactly like the other function code. So you just merge them together. And sometimes they are almost identical and they have just one variable different. So you can pass that one variable as a parameter. So this was our pseudocode. We're going to take the pseudocode, we're going to translate it to C++. So when you're done with your design document, you're going to take your pseudocode, you translate it to C++. Now you worry about the C++ code. You're not thinking about the problem. You're not solving anything. For those who say, after I wrote the code, I had to change a lot in my design document, the answer is you didn't pay attention to your design document. Good. Well, so there might be some changes that you find that in your coding, but it shouldn't be a lot. If you're spending a lot of times to go back and forth, that means you did not think well enough in your design time. So we take this one, we translate it to C++. So we see here it says radius equal 1/2 of diameter. That means I have to find my diameter and get it half of a diameter. And then it says the area equal pi times radius. So that would be that one. And then the return price, the return is the price divided by area. So I could potentially copy and paste this one. And then I'm thinking, okay, for these variables that I have, just like you were doing it in your program, and say, okay, what variables do I need? I need radius. So I have to declare radius inside here. I need diameter. Diameter is coming in as a parameter. I need pi. I can declare pi as a constant inside here, or global constant. And radius, we already have it defined. And then area, I need the area, and area is declared internally. And when I divide price by area, the price is coming in as a parameter, and area is being calculated here. And I'm going to return this. Now, remember what I have been saying all along. what is going to be the problem with this? If I write it like this, what's going to be the problem? So diameter is integer. I'm dividing integer by integer. Remember, when I divide integer by integer, my decimal points goes away. If I lose my decimal point, my radius, then my calculation is not going to be correct because I don't have decimal point, it's not going to calculate it correctly. So I have to fix that. We talked about typecasting, previous sections. So one way of fixing it is through typecasting. So we can use typecast double to do it like this, either to true or diameter. We can do it that way. Or what we can do is I can just change the true to 2.0. I don't like to type that much, so this would be my preferred way of doing it. And instead of using all this typing, I would just use 2.0. And that way it's going to guarantee, remember, if I have a double anywhere in my equation, the whole thing is going to change to double. So when this is double, the diameter becomes double, and then double divided by double is going to give me a number with a decimal point. So the display is in your book. You might want to practice this. You want to type it in. Remember, you have the code available for your book, so you can download the code, play with it, move it around. So this is my declaration with the comment on the top. My definition is on the bottom, and this is the function calls that I have over here. So same function call with different value going in. So at this time, my input function, because I need 4 things to come out of my input function, and we just know the function would return 1 thing, we're going to postpone to chapter 5 to do our input function. So this input function is asking a user, and it's going to return 4 things. And right now we don't know how to return 4 things from a function. We just know how to do function with 1 return value. And with our output, again, for the output function, generally we don't have any return value. So we're going to learn about functions with no return value for next chapter. So for now, we're just doing the processing. And if we have a input that has a return value of 1, then maybe we can create a function for that one. Okay, so that's the way this one is going to be. Take a look at it in your book. And this is my function definition. So we did see this already, and sample run. Okay, one of the things that we have to do is we have to test our program. So we just write the code and we believe ourselves, we did such a wonderful job and we think everything is going to be fine, which most of the time is not going to be fine. So we need to do some testing. So for that, if this was a real life project or for the higher courses, we would create a part of our design document. It would be a test design. How do we test our program? And then we're going to put some boundaries that we're going to be testing, and then we're going to test with those data to be sure we have the outcome. Sometimes we have to do it ourselves by hand outside of the computer to get some kind of a result. Sometimes we get sample data from the user. So for example, for the problem that we did, the Roman numeral, your book was giving some sample data that you could see what's coming out of it. But it's always good to have some things to check, so we can check boundaries. So for example, when you have your input and your input has to be valid, you want to put some number that's not valid to be sure that your validation is working. You want to put some numbers that may crash the program or some numbers that's going to work for the program. So for example, in this one, because you don't have any data from the user, you're going to put some number for the large pizza, you're going to put some numbers for the small pizza, but you have to know what's the outcome. So you know the program is doing it correctly or not. So you calculate it yourself, you create your own data, and then you test it with those. Okie doke. So just gotta make a mental note that every time you have a division, you have to check it to be sure it is not integer by integer. If it's integer by integer, it's two conditions. Either you're doing it purposely or you forgot about it. So if you forgot about it, you have to fix it. If you're doing it on purpose, put a comment after that so the next person who's going to look at it, they don't have to think about it. Okay, so if we do our design document correctly and we write our pseudocode, translating the pseudocode to code shouldn't be too long and shouldn't take that long to do it. So again, when you're doing your pseudocode, when you're doing your design, you're not thinking about the syntax and all those things that might go in there. As you go forward, you might have some things specific to the language, but the first time around, I don't want to have it language specific. So when you say return the function, that's fine. Then some languages might call it, like Java, it would call the function method. So we are not going to be writing those specific to the language. So if we send it somewhere and they want to write it in Java, or we decide that we want to change it to Java, the design document is not going to change. The coding is going to change. Okay, so that ends this section. Take a look at this. Be ready to talk about it in the class so we can go over these things in the class.